Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to talk about Bernoulli distribution. Already in our previous video we have seen all the types of distribution. Now one by one we will try to understand about this kind of distributions, and the major thing about this distribution is that in this distribution you will be able to see that each and every distributions are different, and over here you'll be having a lot of parameters. The most important thing about the distribution is that how is the distribution basically getting created. We'll try to understand how to probably calculate the mean for this distribution, how to calculate the standard deviation of this distribution, how to calculate the variance of this distribution, and what are the examples that probably leads to this kind of distribution. Everything will be specifically getting covered. Now, in the upcoming series of video, you will also be seeing different kind of distribution, and I will try to make sure that I'll try to provide you real world examples so that you'll be able to understand. Okay. So first of all, we are just going to go ahead and discuss about Bernoulli distribution. Now let's go ahead and just understand the definition of Bernoulli distribution. So a Bernoulli distribution is the simplest discrete probability distribution. Now, since this is having a discrete random variable, in order to create this distribution, we will be using probability mass function. Okay. It represents the probability distribution of a random variable that has exactly two possible outcomes: success with probability P and failure with probability 1 minus P. It is also used to model binary outcomes such as coin flip or yes or no question. Okay. So if I probably go ahead and just see the definition, first of all, this entire distribution is for a discrete random variable. This is the first and the foremost important property. Since this is a discrete random variable, the kind of distribution we will be creating will be using probability mass function. Coming to the second point, here with respect to this, you perform any trial or experiments, the outcomes are binary. The outcomes are binary. That basically means the values can be either zeros or 1. So let's see some of the examples over here. So first example is that, let's say that I'm tossing a coin. So in the case of tossing a coin, I will be getting heads or tail. So there are only two binary outcomes. So let's say if I go ahead and say what is the probability of a random variable x to come as head, I can mention it as 0.5. Why? Because I'm considering this as a fair coin. So what is the probability of getting head? It is nothing but 0.5. Similarly, what is the probability of getting tail, right, of this random variable x to get tail? It is very much simple. It is nothing but 1 minus 0.5. Let's consider that I'm going to mention this as p. Then this will be 1 minus p, right? So when I say 1 minus p, I'm actually going to get 0.5, which I can also denote it as q. Okay. So here you'll be able to see I'm having two important parameters. One is P and one is Q. Here Q is nothing but it is 1 minus P. Since the outcome is binary, if for one outcome the probability is this much, for the other outcome it will be just 1 minus for that particular outcome, right? So this is one kind of example. Second example, I can go ahead and say whether the person will pass or fail. What is the probability? So in this scenario, if I go ahead and write, hey, the probability of the person to pass is 0.4, then the probability of the person to fail will be nothing but 1 minus 0.4, which is nothing but 0.6, right? So I hope you are able to understand the specific examples. Here, the experiments or the trials that we are going to perform, the outcomes are going to be binary, and there are two important parameters. So let me just talk about the parameters that are used over here. Parameters that are used over here. Okay. So one is nothing but 0. So first of all, we will be using these two parameters, that is P comma Q, right? Always remember your P value will always be ranging between 0 to 1. Right? Since we are talking about probability and it is a binary outcome, it will always be ranging between 0 to 1. And if I probably consider about Q, it is nothing but 1 minus P. Now let me go ahead and take one important parameter which is called as K, and this value will be 0, 1. And why I'm actually writing K? This indicates my two outcomes. Okay, that is 0 and 1. I will consider 0 as success or 1 as success or 0 as failure, right? So I can also go ahead and just write probability of success and probability of fail. When I say probability of success, I'm basically talking about k is equal to 1. Let's consider this. If I'm talking about probability of fail, I'm just going to talk about k is equal to 0. Okay. So these are the basic things. Now let's go ahead and see this diagram. Okay. Now here, let's consider this is one of the trial. So this is one of the trial. In this trial, which is denoted by this red line, probability of x is equal to 0, right? Of one of the event is 0.2. So for the other event, that is x is equal to 1, it will become 0.8. So this is one of the red line and this is the other red line, right? And we are going to use probability mass function to construct this. Similarly, when probability of x is equal to 0 is 0.8, then probability of x is equal to 1 will be 0.2, because 1 minus 0.8 is 0.2. Similarly, the third trial, you will be able to see probability of x is equal to 0 is 0.5. So if this is 0.5, this will also be 0.5. Okay. But still, we really need to understand how, with the help of probability mass function, we can create this particular plot. Okay. So let's go ahead and let's understand this. Okay. So here now we are just going to go ahead and understand about probability mass function. Now let's consider an example. Okay. A company has launched a phone. Okay. Launched a new smartphone. Okay. Let's consider this smartphone name is A. Okay. A. Now, what we have actually done is that let's consider that I'm probably providing a review for this phone A. Okay. And let's say that I will just go ahead and probably mention that I am satisfied, or I'll just use two terms. Good product. I'll say, hey, this is 60% good. Let's say according to my rating. Okay. And I'll say bad, or instead of writing good or bad, I'll say I will use. Okay. So I will say use. I may say that, hey, 60% I may use it. Okay. Not use, then what will happen with respect to not use? It will be nothing but 100 minus 60, which will be my 40%. So these are my two scenarios, right? These are my two values. This can be P, this can be Q. Q is nothing but 1 minus P, right? Now with respect to this, see, if we go ahead and construct a probability mass function, why we are doing probability mass function? Because this is a discrete value, right? So here I have two 1. One is zeros and one is 1. Let's consider not use is basically the 0 value, and this is 1 value based on K, because K, two outcomes we have for every trial. So over here, you'll be able to see for 0, I may go ahead and construct a building. This will probably give the value as 0.4. Let's say I'm just going to construct it over here in my y-axis. Let's say this is 0.4 and this is 0.6. Okay. Then for the one event, you'll be able to see that I will be getting this value, right? So that is what we have constructed like this, right? Over here, right? This is basically saying 40% I may not use this phone, and this value is basically 60% I'm using this particular phone. This is the kind of probability that I'm actually mentioning, that I may like this phone, I may not like this phone. Okay. And company has launched this smartphone, and it is, we're just trying to show you an example with respect to Bernoulli distribution. Okay. Now, in order to construct this graph, we basically use PMF. So let's go ahead and talk about this PMF. Now the PMF notation, mathematical notation that is specifically given over here, we'll go ahead and write down this notation, and then I will try to simplify this notation over here. Okay. So for this notation, it is basically given as probability of K multiplied by 1 minus probability 1 minus K. Okay. So this is the formula to probably create this PMF, that is probability mass function. And with respect to this, we will be getting this distribution. Okay. Now let's talk about this, what exactly this is. Let's say if my K value is equal to 1, if my K value is equal to 1, then you know what is my P value? My P value is nothing but 0.6, right? So let's consider over here. So here I will go ahead and write what is the probability for K is equal to 1. It is nothing but P to the power of 1 then I will go ahead and write 1 minus 1. So this entire thing will become 0. So this answer that I'm actually going to get is P. So here you can see when my K is equal to 1, I'm actually getting the P value, right? P value. That basically means when my probability of K's success, I'm actually going to get the P value. Okay. Similarly, if I go ahead and calculate the probability with K is equal to 0, which is my other outcome. Now, if I go ahead and apply in this formula, then I'll get P to the power of 0 multiplied by 1 minus P. Then it is 1 minus K. It is nothing but 1. And this I'm actually getting it as 1 minus P, which is nothing but Q. So this is what this diagram is all about, right? When my probability of K is equal to 1, which is my success, I'm going to get the probability of P value, right? But when my probability of K is equal to 0, I'm just getting 1 minus P, right? So if I say, hey, my probability of, instead of X, I've told as K, okay? I've given the notation as K. If the probability of K is equal to 0 is 0.2, then the probability of K is equal to 1 will be 0.8. That is nothing but 1 minus P, right? So this is what I have probably proven from this particular formula, right? And this formula actually helps you to construct this entire distribution that we have seen, right? So let's say for this, in this scenario, I'll say when the probability of success is 0.2. So here, if this is my P value, this will basically be my 1 minus P value, which is nothing but 0.8, right? I hope you are able to understand. And that is what we have proved it over here. So please make sure that you remember this formula. Okay, P to the power of K multiplied by 1 minus P to the power of 1 minus K. For both the outcomes, if K is equal to 1, I will be able to get P. If K is equal to 0, which is for the fail rate, I will be able to get Q. Okay. Now I can also go ahead and write a simplified format to construct this PMF. The simplified format will be that this will basically be my PMF, and this is denoted by Q is equal to 1 minus P if K is equal to 0 and P if K is equal to 1. This is the same thing, right? From this same formula, we are able to get this same thing. If the K is equal to 0, then I'm just going to get the Q value. If K is equal to 1, I'm going to get the P value, right? So this is how you specifically go ahead and determine your entire PMF function, and through this, how you construct this entire distribution. Okay. Now, let's go ahead and talk about the next one. As you all know, for every distribution, we need to know about the parameters that are basically going to be used, what are the outcomes, whether PDF or PMF function is basically used. But since this is a discrete random variable, here we are just going to use the PMF, that is probability mass function. Then how do you construct this probability mass function? For that, there will be a separate formula. Okay, we'll not go in proving this. Okay, proving will probably take additional 10 to 20 steps. I feel proving is not that important based on the syllabus, but we really need to know about the data, how the data looks like, how the data distribution is basically created, what formula is basically applied. Now, since we already calculated the PMF, now let's go ahead and calculate let's find out how to calculate the mean of this Bernoulli distribution. Now, this is really important. How do we calculate the mean of Bernoulli distribution? For every distribution, you have some kind of mean, median, mode, right? Variance, standard deviation. So let's go ahead and talk about this. What is the mean of this Bernoulli distribution? Now understand one thing, guys. If I probably take this as an example, okay? If let's take this as an example based on my feedback, right? I'm saying, hey, 60% I'm liking this product, 40% I do not like this product. Okay. Now, in order to compute the mean, right, and understand, let's first of all go ahead and compute the mean. In order to construct the mean, we basically calculate the expected value of X, and the formula is very simple. It says that, hey, So here, what I will basically do is that I will just go ahead and write one formula. I'll say, hey, summation of I is equal to 0 to K. So K value is either 0 or 1. K multiplied by P of K. Okay. Now, you know what are the K outcomes? The K outcomes are 0, 1, right? So the K outcomes are 0, 1. Okay. The P of K is nothing but what is the probability of, let's say, not liking the product? It is 40%. And what is the probability of liking the product? It is 60%. So when I say k is equal to 0, right? When I say k is equal to 0, or let's go with this way, okay? Since we need to do the summation, here my next step will be, right? I will just go ahead and write for k is equal to 0, right? For this k value equal to 0 to k, okay? K basically means 0 to 1 also I can write, because this is a binary outcome. So let me just go ahead and write 0 to 1, okay? When the value of k is equal to 0, so I will take k is equal to 0. What is the probability of 0? Probability of 0 is nothing but 40%. So here I will just go ahead and multiply 0.4, right? So this is nothing but 0 multiplied by 0.4 plus, when I say k is equal to 1, this is 1 multiplied by probability of 1. What is probability of 1? It is nothing but 0.60. Now here you will know that this value will be 0 and this will be 0.60. Now when I am getting 0.60, what exactly this is? This is nothing but my p value itself, right? This is what is my probability of 1, right? Which is nothing but it is equal to p. What is p over here? P is nothing but 0.6 and q is nothing but 0.4, right? That is what we are basically calculating. And this, when we say p is equal to 0.6, what does this basically mean? Probability of 1 is 0.6 and here probability of 0 is 0.4. So when we calculate the mean with respect to this distribution, you'll be able to see that the expected mean that I'm actually going to get is nothing but p value, right? So this is how we probably get the mean of the Bernoulli distribution, okay? So based on this distribution, guys, if I'm getting the mean of this Bernoulli distribution as 0.6, so I can probably note it over here. So somewhere here, your 0.6 value will come, right? Now similarly, let's go ahead and compute the median, right? So now if I just go ahead and compute the median. Now for computing the median of Bernoulli distribution, let's go ahead and write it down, okay? Median basically means the central element, right? Here mean, what we have done with respect to the mean, we have taken the probability with respect to the outcome and we are doing the summation with respect to the other probability with respect to the outcome. And finally, I'm able to see that, hey, the mean of a Bernoulli distribution value is p, okay? Now, when I talk about the median, see, median is basically mentioned by this notation. So here, if I really need to compute the median, I will be depending on the p value. If the p value is less than half, that basically means if the p value is less than 0.5, okay, then you will be seeing that since in the median I need to take the central element, okay. Now since my p value is already less than half, then my median will be exactly equal to 0, okay. Then if I say, hey, if p is equal to half, then my median, if p, the exact p value is half in the center, then I can have the median value of 0, 1. That basically means the median can also have a value like 0 or it can have a value as 1, okay. I will talk more about it, why I'm saying like this, right? And similarly, if I say, if my p value is greater than half, then you'll be able to see that I will be getting the median value to 1. So in short, what we are doing is that if any of my p value is greater than 0.5, I'm moving towards this 1 probability. So I'm actually getting the output as 1. If it is less than this, I'm going to go towards 0. And if my probability value is exactly, if my p value is exactly 0.5, right, then I am probably depending on both of them to probably show the output, okay. Now you may be thinking, Krish, why you have specifically done in this way, okay. What is the main aim over here? If I really want to simplify this entire thing, I can also go ahead and write something like this. The median will be equal to 0 if q is greater than p. The median, since we are dependent on the central element, median is equal to 0.5 if q is equal to p, and median is equal to 1 if q is less than p, right? So this and this are almost equivalent, right? Here, whatever q value is, like if the q value is greater than p, here you are going to get the median as 0. If the q value is equal to p, you are going to get the median as 0.5. If q value is less than p, you are going to get a value of 1. When I say, hey, it can be dependent on 0 and 1, in short, I'm just trying to pick up the middle element with respect to the probability, right? But usually in most of the scenarios with respect to probability, and even in some of the machine learning algorithms, if you see, like logistic and all, we keep a threshold value. If a value is greater than 0.5, we probably move towards 1. If the value is less than 0.5, we probably move towards 0. Okay, something like that. So I hope you are able to understand. Now similarly with respect to the mode, so I will also go ahead and write for the mode, right? The mode for the Bernoulli distribution. And here also it will be very simple. If the p value is greater than q, then p will be the mode. Or else q will be the mode. Whatever will be the p value, that will be the mode. Because with respect to mode, we basically select the most frequent occurring element, right? But here, since it is more about a probability distribution, if the p value is greater than q, we will consider this as the mode, else q will be considered as the mode. Now let me do one more thing. Let me just showcase about variance. Now variance is also really important and you need to understand this. How do we go ahead and calculate the variance and standard deviation? Now guys, variance over here, if we probably see at the formula, variance is nothing but how far we are away from the mean, right? For every k outcome, right? So here, if I go ahead and compute the variance, you know the k value is 0 and 1, okay? And your p value is nothing but 0.4, sorry, not p. The probability of k is equal to 0. So what is the probability for k is equal to 0? It is nothing but 0.4. And what is the probability of k is equal to 1? It is nothing but 0.6. Now we know that this is p, this is q. Let's consider it. Okay. So in order to compute the variance, the formula will look something like this. We will take this probability for k is equal to 0. Let's go ahead and consider it. It is 0.40 multiplied by, we will take the outcome 0 and how much far it is away from the mean. The mean is 0.6 and we'll just going to do the square. Okay. Similarly, we will take the next probability with respect to k is equal to 1, 0.6. Then we'll take this 1 value. Okay. Since the outcome is 1, k is equal to 1. And we will see how much far it is away from the mean. And then we are going to do the squaring it up. Now here, if you go ahead and compute it, 0.40 multiplied by, if you see this value, right, 0.6 whole square, it is nothing but 0.36. Then you are going to get this 0.6 multiplied by 0.16, right? Because 1 minus 0.6 is 0.4, 0.4 whole square is 0.6, 1.6. Now if I go ahead and do the calculation, I'm going to get it as 0.4. Now 0.24, don't you think this one 0.24 is nothing but it is the probability of k is equal to 0 multiplied by probability of k is equal to 1, right? You know that probability of k is equal to 1 is indicated by p and this will also get multiplied by q. So in short, your variance is nothing but it is the multiplication of p and q. And similarly, if I need to go ahead and compute the standard deviation, it is nothing but square root of p and q. So these two formulas are specifically used to calculate the variance and standard deviation. Okay. Now for this example, I have almost shown each and everything, right? How this distribution looks like, what is the mean properties of this distribution. You really need to have a discrete random variable. The outcomes are binary. Some of the examples that I have shown. And for every distribution, you'll be having some set of parameters. You'll be seeing that how this distribution is constructed. It can be either PMF or PDF. Then with respect to this, if this is a PMF, what is the formula basically used to construct this entire distribution? Then we have also seen how to calculate the mean of the Bernoulli distribution, how to calculate the median of the Bernoulli distribution, how to calculate the mode, variance and standard deviation of the distribution. And obviously you have also understood what is the examples of Bernoulli distribution. Any distribution that has an outcomes as binary. So I hope you are able to understand this video. This was it. Now, as we go ahead, we will also be seeing about different distribution, which will be quite amazing, right? So yes, this was it from my side. I will see you all in the next video.